shear force diagram and bending moment diagram. Before we speak about any example, we need to see three main integrations. The first integration is for this line, and it will be like this. And in the second integration, it will be a curve like this. And in the third integration, it will be integration for a curve, and it will be more curved. These three integrations are very important for our diagrams: the shear force diagram and the bending moment diagram. For that, it was very important to explain it and show it before we get into any example. For that, let us now see our example. In this example, he gave me two distributed forces. This is the first one, and this is the second one. And if we want to find our diagrams, we need to determine our reactions around the bin A and around the ruler D. For that, before we do any integration or any reactions, we need to determine our centroid for each force. For that, the first centroid, it will be exactly in the middle of the yellow part, and that means it will be have a distance 1 from the bin A, and this is our rectangular and have a height by 50 kilonewton per meter and base 2 meter. And our second distributed force, the centroid of it, it will be exactly also in the middle of the green part, and it will be here, have a distance 1 from the ruler D, have the highest 20 kilonewton per meter and base 2 meter. Now, after we determine our centroids, we need to find our reactions around the bin A and around the ruler D. And if we want to determine our reaction around the ruler D, we're going to take the moment around A, and it will be equal 0. And as you know, in that moment, even it will be clockwise or anti-clockwise. For that, for the first and second distributed force, it will be with the clockwise, and that means it will be negative. And if we find our reaction dy, it will be anti-clockwise, and that means it will be positive. Now let us see. It will be like this. The first centroid, 2 multiplied by 50, have a distance 1 from our bin A, and our centroid, the second centroid, it will be have a distance 5, and as you see, it will be 2 multiplied by 50 because it's rectangular. And if we do our calculations, we will define or determine our reaction dy, and it will be equal to 50 kilonewton. After we determine our first reaction dy, we can determine our reactions around A, and it will be ay and ax. For that, if we want to determine our reactions around A, we can do it with two ways. The first one, we take sigma f of y equals 0 and sigma f of x equals 0. After that, we will take our forces around x and our forces around y, and do our calculations, or take the moment around D and determine our reaction around A. For that, let us do this, and this is the way I like it. For that, if we take the moment around D, our AX reaction, it will go because it go directly to the moment, and our reaction AY, it will be stay because he have angle 90 with the moment D. For that, let us do it as exactly as we did with the reaction dy. Take the distance from the first centroid and the second centroid and multiply it and divide it, and after that we will get our reaction. For that, let us see. First, we have our reaction AY. It will be negative because it have the direction with the clockwise, and our distributed force, it will be anti-clockwise as it's C, and we will do our calculation exactly as we did it with the first one, and it will give us the reaction AY. But I want to ask you a question. Why we didn't take our reaction AX in this one? Because it's moment, and our reaction go directly to the centroid of our moment. For that, we can determine it in the moment, but we can determine it if we take sigma f of x, and it will be equal 0. And why it will be equal 0? Because there is no other force in the x-axis. Now, after we determine our reactions, the first one and the second one, we can draw our shear force diagram and our bending moment diagram. For that, we will go up 90 kilonewton. After that, we are going down 100 kilonewton because the direction of this force down, and it will go until stop in -10. After that, we don't have any force. For that, we will go straight. After that, we have another centroid 40 kilonewton, and that means we will go down to -50, and we have a reaction 50 kilonewton, and it go up. For that, we will go to our 0. After we determine our shear force diagram, we can draw our bending moment diagram. Now we will draw the first curve because we have this line, and if we integrate this line, it will be curved as we see in the start of this video. For that, it will be like this. But if I want to determine the maximum of this curve, we need to take a cut from a part that it will be easy to determine it. And before even to take this cut, we need to know why we will take this cut. For that, if we want the maximum, we will take the area under this curve here. We know the height, but we don't know our base. And the law of area, triangle area, is half multiplied by the height multiplied by the base, but we don't know the base. For that, we need to determine our base. For that, we will take a cut from this part because the shear force here equals 0. For that, if we take it, we will go like this, and we have here, almost here, distributed force, and we will cut it from here, and it will be like this, as you see here. We have a new base x, but have the same height, and if we will determine our sigma f of y, because we don't need our moment or our sigma f of x, we only will use sigma f of y, and it will be like this. And the sigma f of y have three main forces. The first one, our reaction, and our second force is rectangular, and the third force will be the cutting force, or the V force, or the shear force. For that, let us see our forces, and it will be like this. Our reaction go up, and our centroid, the new centroid, will be go down, for that the negative, and our V force will go down also, for that it will be negative. After that, we can calculate the base x, and it will be equal 1.8. After we determine our base, and for this area is the same base for this one, for that it will be equal half multiplied by 90 multiplied by 1.8, and that will give us our maximum of this curve, and it will be equal 81 kilonewton per meter. After that, if we integrate this line, it will be straight like this, but with a little bit, as you see, angle. After that, if we want to integrate this, it will be also a curve. But in this time, if we want to know the maximum, we need to cut it and do exactly the same as we did with this one. And that our example about shear force diagram and bending moment diagram. And thank you for your listening and your time.